All right. Good evening, everyone, and happy Halloween. Let's go ahead and get started. I see people are dressed up, few of them. I did think about a costume. I know Eric was saying that, but then I had this idea, but then I was like, it might be like too scary for you guys. Yeah, so I was thinking I'm going to dress up like a whiteboard and put an interview question over here and there's a class. Yeah. One of my course, I think I'm gonna try that and walk in, like stand over somewhere. Yeah.
Make people come up and solve you.
Yeah, it'll just go by and stand over there. So then it might be a little bit scary or mean also. So I was like, okay, I'm not going to do that. All right. So last day of MySQL. Any questions? How do you guys feel about MySQL? Good. Did you say tight? It's what?
It's all right.
Oh, wrong. Right. I was okay. So when I say MySQL, I'm talking about two different parts. First, just the database, and the second, Node.js. What do you guys think about the Node.js MySQL? No? Maybe? Okay. So let's go ahead and get started. We'll start with a quick revision. I know it says pop quiz, but we'll do it together. It's not. We'll just create a simple table. We'll make sure that we understand before we move on. So today we are actually going to look at a little more MySQL, but this time we are going to look at large data sets, right? Almost like between 1,000 to 5,000 lines of database. Okay. So right now we've been creating tables and we've been inserting data like 3 to 5 data set. This time we already have some Excel files. We'll kind of load them up and we'll see how do we query large amount of data. Okay, the largest right now is 5,000. Again, 5,000 is not a super huge data when it comes to production databases, but for now, for our purposes, that will have to do. Okay, so we'll get there. Before that, let me go ahead and show you guys. Okay, so this is a super straightforward exercise. We'll do it together. This one, what we have to do is we have to create a new database, all right, connect to MySQL, create a new database, and then we're going to create a new table. The table is going to have just two columns, ID, which is going to be an integer, okay, and auto incremented, and the second column is going to be a text field, varchar something. Okay, and then we are going to insert 3 rows into our new table. All right, that will be the first part. The second part is then we are going to write our Node.js application. So we are going to connect to the database that we just created, and then we are going to just simple run a select query from our Node.js, print those records out. Okay. All right. So you can follow along, and then I will do it. Just help me out. We'll do it together, and it should be pretty straightforward. Okay. So now it doesn't say what database. It can be anything, and I'll choose like a database for schools. Okay. So we'll create a database for schools, and then we'll have a table called schools, which will have just 2 columns. Okay. All right. So let's go. Let's see. Basim, would you start us off? What's the first thing I need to do? Oh, by the way, if you guys didn't know, if you haven't congratulated Basim, he got a job as a web developer. So did you already start? Yeah, this was today. This is your first week, right? Yeah. How's the week going?
It is really today.
Okay.
Like the one guy doesn't know what's going on, so I sit in the
Yeah, yeah.
So, but it's cool. It's really cool. Like getting my own computer and stuff.
Okay.
It's pretty cool.
Awesome, awesome. All right, maybe you can ask Basim, add him on LinkedIn, and kind of get some more details about it. Okay. All right. So I want to create a database. What's the first thing?
Yeah. So create database. You're going to
Create database, and then this is the name. Okay. So we said school, so we're going to say school underscore DB. Okay. Run this. Green, successful. Let's refresh it, and there's my school database. Okay. The next thing, Josh. Josh, yes. What's the next thing I need to do?
you want to use that same database.
All right. So use, oops, school underscore DB. Okay. And then,
And then you can create a table if you want.
okay. Right. So the next thing we are going to do is we are going to create a table. So create table, and let's call it schools. Okay. Let's see, Andrew, what's the next thing? So I have my create table part.
So like not variable, but you're gonna make different
Mm-hmm.
terms for that. But
Different, you're close. What is it? Different columns, right? All right, so we are going to create columns now. And from the description, we need to create two different columns. All right, so the first column is going to be our ID. So let's go ahead and create that school underscore ID. Okay, and this is going to be our data type integer. Integer. And then this is going to be auto incremented. So auto increment. And then let's say it cannot be null. All right. And then the second column is going to be name of the school. And that's going to be string or varchar. So name, let's say varchar, give it a, let's say 100. Okay. And say not null. Okay. Tyler, what's the last thing over here that I need to do? Primary key. All right. So I have my IDs. I have auto incremented everything set up. The only thing missing is my primary key. All right. Excellent. So let's go ahead and do a primary underscore key, and this would be this column. Okay. And let's go ahead and run this and see. Oh, there is some error. What am I missing? Auto increment. What does it say? No database selected. All right. So I need to run this thing, and that's better. Okay. So I should have a table with two columns. Let's open this up, schools, and there are my two columns. The first one is my primary key, and that should take care of that. Okay. Um, Now, any questions on this? We just created a database, one simple table, two columns. All right. So in your solutions, you might have seen two different SQL files. One is called schema. All right. So what that file says is, so for example, over here, right? And Sarah was asking that question the other day. So over here, if I close this, these queries kind of go away, right? If I'm going to close this, this query goes away. My table is there, but the query kind of disappears, all right? So if you want to share this query, once you're on your project, you want somebody to set up this exact same database. What you do is you save this into a file called something.sql, okay? And then what you do is you can upload it to your GitHub. Basically, anybody can open that SQL file and then run the same exact query, okay? Um, let me show you, and then we can go from there. So let's say I'm going to go ahead and save this thing, and we are on exercise number 11. So let's go ahead and create a new folder here, and we'll call it school. Okay, in this folder I'm going to save this, and I'm going to call it, you can call it anything you want, but you will see by standards the SQL queries that are going to create your database and table are called schema, right? This is the schema file. What it basically tells anybody who sees the schema.sql, that this has all the queries that are going to create a database and a table. Okay. By standard, the schema.sql does not contain any insert queries, does not contain any select queries, does not contain any other queries other than creating a database and then creating a table. Okay. Again, there's nothing stopping you. You can put everything in a single SQL file and save it, but that's the definition of that word. So if you see a schema.sql, you will see it will only have creation of the database and then creation of the tables. That's why it's called schema.sql. Okay, so I just saved this into a file, and in addition to this, you will also see in your solutions for schema, you will see the statement called drop database if exists school underscore db. Okay, so the purpose of this is that somebody who is running your schema.sql, the intention should be that if the database already exists, it should be removed, cleaned up, and start again. Okay, that's the purpose of your schema.sql. If you already have a database set up and everything is good, you shouldn't be running your schema.sql every single time. Okay, so that's why this drop database comes in. Just be careful if you run it twice, and if you have some data in your table or database, it's going to wipe out everything. Okay, so I'm going to, for example, I'm going to save this, and what should happen is I'm going to now delete my schema, and if my SQL is correct, I should be able to just create it from my schema.sql. Okay, let's suppose one of you guys created this schema. I downloaded your project, I cloned your project, I found this SQL file, and what I have to do is I'm going to do file, open SQL script, and then I'm going to go to and find the SQL file that is there, open this, and I should not have to do anything. All I have to do is just run this file and everything should run automatically. Okay, select it, run this, and everything should be successful. Let's refresh it, and there's my database with my table. Okay, so this is the purpose of this is how you can save your queries instead of they kind of disappearing, because as soon as you close your query tab, if you haven't saved it, they're all going to go away. Okay, and if you save it, the extension is .sql. Give it a name. By standard, schema means that all the queries that are in schema.sql are going to create a database and create a table. That's what they mean. Okay. Any questions? Good. All right. So the second file that you see in your solutions is called seeds.sql, right? By seeds, what it means is that you are inserting some data. That's what it means. So once you have your schema created, you want to insert some data inside it. You can create, and you can save those queries. So you would create seeds.sql. Again, those are just insert queries. That's all they are. Okay. So I have my table. What I have to do is I want to I want to insert some data, right? And then I'm going to save the SQL file in my SQL in a .sql file. Okay. So if somebody wants to run this, the first thing I'll have to do is use because I'm going to save this eventually, and then whoever opens this file up, they can just run it. If I don't have this use, then there won't be any database selected, and you'll get an error saying, hey, select a database. Okay, so that's why it's there. Or the other thing, you can double click it, but that's kind of a bit more manual. This should be able to execute without any double clicking, highlighting the database or anything. Okay. All right. Inserting should be easy. So I have two columns, but one of them is primary key. All right, so I just need to add one column data. You guys see that? It's a primary key, it's auto increment, so I don't have to worry about adding numbers to it. Okay, let's go ahead and insert some insert 3 rows is going to be insert and then into, right? And then the table name, which is schools. Okay. And then which column am I inserting to? The name column. All right. And then what values am I inserting? Okay, so I just need a name for the school. So let's go ahead and insert a school name. Okay, did I spell that right? I think so. All right, so this should go ahead and insert a name of the school. So let's go ahead and test this out. And successful. Let's go ahead and insert 2 more rows. So same thing, insert into table name, column name, and then what are the values for that column? You only have single column. Institute. Okay, and successful. Let's insert the last one. Again, the column name and the values for that column, since it's only one, should be just one column. Okay. View buttons. Okay. Let's go ahead and save this into our file, and we'll call it seeds. So I'm going to say save script as, and then also seeds.sql, and this should go ahead and save it to my seeds file. Okay, so once somebody download this file from my project, what they have to do, the first thing they're going to do is run schema, open this file, run the schema file. This will create a database and a table. The next thing they will do is just open this file and run everything inside it. Okay, so you will have a database, table, and then some values inserted into it. Okay, let's close this, and then let's do a select query. I'm going to select this database, run this query to make sure we have everything. Select star from schools. Okay, and there are 3 rows inside it. Okay, with 2 columns. Simple database and a simple table. Okay. Any questions on creating, or any questions on the queries? How did we create the database? How did we create the table, columns? No questions? Everybody understand? You guys would be able to create tables? Okay. Good. All right, so the next step is I have my table created. How do I use Node.js to access this data? Exact same query. How do I run this and pull this data into my Node.js app? All right, so we're going to shift to our Visual Studio, and then let's go back here. So this is my folder. Let's go ahead and create our JavaScript file, schools dot, school.js. Okay, let me make it a bit bigger so you guys can see it. All right, so what's the first thing I need to do? I'm trying to connect to, from Node.js, I want to go ahead and connect to MySQL. What's the first thing? npm install MySQL. Let's go ahead and do it since Josh already mentioned that. Npm MySQL. Okay. All right, what's the step after this? So I have my installation done. What was that? Required. So I have my installation. Before I can use any of MySQL functions in Node.js, I need to import the MySQL library. Okay. Let's go ahead and create, let's call it const this time since I don't think it's changing. So const MySQL, declare a variable, and then import using the required keyword and the library npm package is called MySQL, and then I have my MySQL. Okay. All right. What's the next step? Connection. So excellent. So I need to make a connection and declare some of the properties what are part of my database. Okay. So let's go ahead and say const. I don't think connection is going to change as well. Let's see. So I'm going to declare a variable const, and MySQL, the variable that I declared, which has imported the package, has a function called create connection. That's what we're going to use. And what is the argument that create connection takes? Object. Okay. All right. So let's go ahead and create a object. What's the first property that we need? Host. And what goes in our host? What goes in our host? Localhost. Now, is it going to be localhost always? No. Once you guys have your database set up in Heroku or somewhere in the cloud where everybody can access it, right? This is going to be that IP address, that URL, whatever that is, right? When we get to that step, we will see. But this is going to be the URL where your database resides. Right now, your database resides on URL called localhost or 127.0.0.1. Okay, and you can make sure of this is if you go to your MySQL, if you go back to your home, you will see this connection over here. Okay, and this IP address, this is what we are trying to type in. So 127.0.0.1 or localhost. Node.js understands both of them. Okay, so that's why we are using localhost, and Node.js is saying okay 127.0.0.1 or localhost, both are same. Okay, the second property, user, before user, port. Okay, so the port number and host kind of go hand in hand together. Right now it's 3306. Again, if you go back to your MySQL and then you look at your connection, it says over here 3306. Okay, again, this is going to change once you deploy it somewhere. Everybody has a different port number and they will tell you what port number to use. Okay, the next thing, Simon, user. All right, what is the user that I'm using? My user name is called root, and the last one, password. Okay, let's go ahead and give the password. All right, so this is all the parameters, all the properties that are required to make the connection. Okay, what am I, is this complete or am I missing something? Yes. What is it? Yes, excellent. I need my database. It's the connection is there, but remember in my host I can have multiple databases, right? Now you are trying to say which one are you trying to connect, right? So this one I'm trying to connect is called schools underscore DB database schools underscore DB. Is that what it's called? School. It's called school. Okay. So now my connection is complete. What's the next function that I need to call? Connection.connect. All right, and connect takes, what's the argument for connect? No, I don't say function, say the whole name. Callback function. There you go. It's not any simple function, it's callback. Callback function. All right, takes in one argument, error, and then you can check, put in the condition if there's any error, throw that so that the execution stops and doesn't proceed. Okay, otherwise let's go ahead and console log some success message with an ID, successfully connected with ID dollar and connection dot thread ID. Okay, so with a successfully connected, we should get this message, and then let's go ahead and end our connection as well. Connection dot end. Okay, I think this is enough, and this should go ahead and create a connection if everything is good. So let's go ahead and run this terminal. Okay, and Okay. Successfully connected with ID this. This means I am able to connect to my database. All right. Any questions? Everybody understands? All right. Let's do the last part. Reading the rows from the database in my Node.js. So I'm going to create a function. Let's call it function read schools. Let's call it read schools. Okay. Let's create a query. Let's call it SQL query, and this is going to be a string. I'm going to write my select query too. So select star from schools, my table name. All right. What is the function that I need to pass this query in? It's called what? Connection dot query. Excellent. All right. And what are the arguments for what's the first argument for this function? The query, the actual string query, okay, the one that we declared on the top over here. So the first argument is going to be my SQL query string, and the second argument, callback function. Excellent. So callback function, and my callback function takes in total are 3 arguments. One of them is optional, so we'll skip the last one. The first one is going to be error, and then results. That should have all my JSON data for all my rows. Okay. If there is any error, I want to stop the execution of the program, throw error, okay, and don't proceed. If this is successful, let's just go ahead and console log our results, okay, and then end our connection over here instead of above. Okay, so let's go ahead and fix that. I don't want to end my connection here. Instead, what I need to do is I'm going to call my read schools function, and this should go ahead and call this function. Okay. All right. Any questions before I run this? Okay. So let's go ahead and run this and see if this is working. All right. So node schools.js. All right. Successfully connected, and then it's able to go ahead and bring me 3 rows, whatever the rows are in my database. Okay, if I want to parse them, results.schoolid or results.name, they should give me all the names of the schools. So results dot oops dot just the school names. Oh, undefined. David. So why am I getting the undefined? Why? Remember there was a property name, but it doesn't work because results is an array. Okay, so what do I have to do to parse this array? I can use a for loop or a for each or just for in, and this is results dot length, and then let's go ahead and move this inside. Oops, replace this thing. Okay, and then let's get an I. Okay, so this is going to go ahead parse all the results and give the name out of it. All right, let's see if this works. Oops. Okay, so this is how I'm able to parse it. I'm able to get whatever property that I'm looking for. It's just like parsing JSON. Okay, all right, questions? Does everybody understand? How do we write queries? How do we make connection? How do we create databases? Maybe? No? Okay, which part? Again, I can go over this again, but tell me which part is confusing. I was asking a question, no, no. I was asking, yes. Oh, no, no, no. Remember, this is an object, you can put it in any order. I follow this order, it looks nice, it's kind of more logical to me, that's all. But it's a property, it doesn't matter which order you put. You can put your database first, you can put your password first, you can put your username later, yeah. Order doesn't matter. Okay, because this is an object, it's going to read the object anyway. Any other questions? Would you guys be able to write something similar? Okay. Yes, Josh. For loop. Since results is an array, that's why I need the for loop. So for each, for in. For what? For in. Anybody know the syntax for in? Okay, so for, and then it's going to be the key in this. So for, what is going to be my, this is going to be my array, right? Results, right? Let's call it res, as in result. Okay, and then you can go ahead and console log result dot name, right? So how does this run? This is saying this is an array. For each element of the array, do this. So this is going to be an array of objects, all right? And then it's going to put each one of the object over here, and then you can access this property. Chris, is it different? Is it different?
Yeah.
Okay. What am I missing?
So in the console log, results, square brackets, res, then document. That can look as undefined.
So, so what it should be? Results. Okay. Okay.
And then
Dot name. It's kind of weird. I don't understand this syntax. So. What is it? Node school. Okay, so as David is saying, the for runs over only in objects. Like if you have an object, for example, an object which has properties, for example, this thing, right? This is an object with some properties. So this is where the for in comes in. It's going to loop through each one of the property within that object. That's what for in is actually used for. You can use it for the array, but you have to do kind of this weird syntax though. So I think for this one, for each or for would be better if you're looping through an array. But you can do it this way. That's kind of looks like a weird syntax. So especially this thing, it's kind of not intuitive. Okay. All right. Anything else related to MySQL connection, reading schools, creating databases? Okay. All right. If no questions, so the next exercise, what we will do is I'm going to give you a data set. Basically, it's a CSV file. All right. You guys are going to open that file, and then you're going to look at what the data is. Based on looking at the data, observing it, you're going to create a table that is going to eventually should be able to take all that data in. Okay, you're not going to insert anything. The only thing is you're going to look at the CSV file, and then you're going to create a database, a table, and the columns by looking at the data set. Okay, so let me walk you guys a little bit more. So this is going to be exercise number 12. All right, and let's look at this file. Okay, so Again, these are not being slacked out. Please go ahead and download it from GitHub. I think these are pretty big files. All right, so the first file and the second file, they both are same as far as the columns go, and the columns go. They both have the exact same column names, everything, right? The only difference is the first file has 1000 rows, the second file has 5000 rows. Okay, so the options are given. Depending on your laptop, some people face one. Eventually, we are going to import all this data into our SQL. Not right now, but what happens is sometimes importing 5000 rows takes a while on some people's computers. So that's why 1000 is given. So if you think that's too much or your MySQL is taking too much time, use the 1001. Okay, I'll come back to it. I'll explain it again. For now, you don't have to worry about it. The thing what we need to do is we need to look at this data set. You guys are going to look at this data set and create a schema. Right? Does everybody understand what I say when I'm saying create a schema? You're basically creating a database and a table. Okay. Before you ask, I'm using a plugin called CSV preview. That's why when I do this, it kind of shows me in this fashion. If you are interested, let me go back and show you guys the extension that I'm using to view this. Otherwise, it doesn't show up. Otherwise, it's going to show you up as um, like this. Okay, if you can read this, that's perfectly fine too. So the extension, if anybody is interested, is called Excel Viewer by Great City. That's the extension that I'm using. Once I have this installed, what I do is I right click the CSV file in Visual Studio and do a preview, and that's why I see this nice like a nice view over here. It's called Excel Viewer, like Microsoft Excel. It's called Excel Viewer by Grape City. That's the extension that I'm using. Okay. Again, this is optional. People do ask me. That's why I'm telling how do I see it in this fashion, and you guys are not able to see it, and this is why I'm using an extension. That's why. Okay. Now I'm not going to go through and let me go through the columns. What I'm not going to go through is I'll give you in a minute. Okay. So here, just concentrate on this. I can give you a quick overview of what each column does, and then you can create it on your own. Okay. So this is a database or a data set of top songs forever. All right. Looks like it's from 19 maybe 50s up until now. Okay. So these are the top 5,000 songs. The first column is the number of position, basically the rank. The second is the person or the artist who sang that song. Okay. The third column is the name of the song. The fourth column is the year of the release, when that song was released. Okay. These columns are basically popularity score. Okay, you don't have to worry about what it actually means, but they are all our popularity score depending on the sales of the song and bunch of other stuff. Okay, the first column is worldwide, like what was the popularity score of this song everywhere in the world. Okay, the first column is world. This column, column number F, or the sixth column, is a popularity score just in US. Okay, the one after that is popularity score in the UK. Okay, the one after that is a popularity score in Europe. Basically, it means non-English speaking countries in Europe. And the last column is international. Any other country that does not fall under these three categories, that's where it comes in. Okay, so the first column over here, again, these are our popularity score. The reason I'm explaining is so that you can come up with good column names, right? Other than that, these should be just numbers to you. Okay, so the first one is a popularity score worldwide. The one is popularity score in the US, popularity score in the UK, Europe, and then international. Is that clear? Okay, again, I'm explaining this so that you can come up with column name. Basically, but eventually look at the data type, try to determine what's going to be the data type for the first column, right? Rank, position, whatever you want to call it, then second, then third, go all the way, okay? And then make sure that whatever data type you're creating will be able to take all of this data in, okay? I'm not saying go through line by line, just do a spot check, make sure the data type that you're using is correct one. Okay, any questions? Yes. Uh-huh. Okay, so E is the popularity score worldwide. So this is some calculation done. They came up with this number, and this is the popularity score of this song worldwide. The one after that, the F column, is a popularity score within US. The one after that is within UK. The one after that is Europe, and the last one is international. So all of them are popularity score. They're just divided by regions. That's what they are. Okay. So what I want you guys to do is look at the data set, come up with the column names, database, table, create a table. Okay. You don't have to insert anything, just create the schema, make sure the table exists, and then I'm going to um, show you how to import this data into the table that you have created. Okay, make sure that your table is correct, because if you try to import this, if your table definition does not match the data set, it's going to fail. Okay, for example, if this column, the column F, if you declare this as varchar, it's going to fail. All right, doesn't look like a varchar. Okay, or if you have integer, what's going to happen is going to kind of truncate. But that we want this exact data set transported over to your MySQL database, right? Right now it's just in a file. Any other questions? No? Okay, so let's go ahead and create a table, create a database, create a table, create columns, make sure they are there in your database, and then I'll show you how to import this data set into your MySQL. Okay? You can use it when Is anybody using the Excel viewer extension? Okay, so just be careful. If you open this, you will see that this is being truncated. um, I had to change some settings. If you are using it, if you go to your um, the only problem with this is it comes with some default setting, and the default setting is only 2 decimal places. So the data set that you open will only have 2 decimal places. Actually, it's not. This is how it is. It has 3 decimal places. So what I had to do is I had to go into the extension settings and kind of change some of the properties. So if you go into settings over here, configure extension settings. Um, so there's workspace and there's user. You want to be in the user setting, and the setting was this one. This is the one that I changed. Right now, if you look it up, by default it says always. So it is going to format numbers in your CSV file. Okay, so the first thing I did, I said don't format my numbers. I want to see it raw. So I said never. And the second option is you will see G2 written over here. Okay. Again, I have no idea what this means. I just read their documentation over here and I kind of figured it out. So the G2 means um, format my numbers to 2 decimal places. Apparently, that's what it means. And .NET, I mean, I'm not. I've been out of the .NET world for a while, so I'm not sure. But looks like .NET does it. So if you see a G2 over here, I removed it, and then you just have to reload it, and you will see 3 decimal places. Yeah, there's a setting for the first column as well. Let me see which one. Yeah, this one. Specify where the lines begin with a comment character. Oh no, not this one.
There's the first row is showing as the header. You don't see the headers. Is there anything that you have to change for that?
Yeah, I'm trying to. Oh yeah, this one. Specify whether the first row is or not. So you have to uncheck that, and then you just have to reload it. I had to reload it, and that's when it shows up. Again, if don't get too hung up on this settings. If even if the first one shows you as not the header, it's okay. Look at the other data set. You should still be able to create a table looking at the second and third. This is just a viewer. It's not changing your data set in any way. Okay, just opening your CSV file according to something, right? But if you are, I kind of shared the settings. That's what you need to do. Otherwise, it will truncate it to 2 decimal places, and then it puts the heading over there. But this is all visualization. Behind the scenes, it is still this data set. Mm. Yeah, just do a spot check, but I think you're right. Just make sure, just do a spot check, but that's pretty close. Yeah. Look at your data set. Don't look at over here. There might be some data behind. There are like 5,000 rows over here. Yeah, but I think you're right. Yeah, it should be. If you are confused, take a look at the raw file as well, just to kind of make sure that you are on the right path. Again, this is just a viewer. It might be hiding some information. At least one information I can see that is hiding. So make sure, just take a look at this one as well.
So should we be creating the
Just the schema. Seeds, this is going to be your seed. You already have that. We'll import it. You don't have to create. That's just schema. Do the schema, run it, and you should have a table ready to be, and I'll show you how to import this data inside that table. But the table and the database should exist before we can import it. Is that done? You got it? What's your primary key? Um, so this data set should exactly match your table. If you have a songs ID, this data set does not have a what's you are adding an extra column now. So this data set already has an ID, right? So you don't need an extra ID. It's going to just add to it.
I figured it should be its own thing. Yep. Create a database, give it a name. then you just say
What is what?
minus
Oh yeah, yeah, yeah. But oh, in real, but right now this is a data set, and that's what it is. Yeah. What is it? Um, yeah, 5,000. So looks like an integer. So don't create an extra ID. Use this one as an ID. Yeah, you can call anything, but you need a primary key, and this will become your primary key. But so the ID is year is this one. Oh, okay. So there's a year 5,000. Just
Going to the future.
maybe I should scroll down so that is this better?
Yeah, so the first column is the position column. Yeah, you can call it whatever you want. But it's if you look at
Does that make sense? Got it.
this is the
So I mean, it can still be named.
you just go all the way down and see the
Yeah, ID, songs ID, whatever makes sense to you. But this is not a like a songs ID. It's actually the ranking of the song. So
Right, rank ID. And that could,
yeah, not even ID. You can just say rank or something. All right. So how many people are done with creating the table? Ooh. Okay. Good. What are you guys doing over there? What?
so it's just like
Want me to repeat the column name? Worldwide, American, US, then UK, Europe. Oh no, there's no America. He was saying it. So the first one is worldwide, then US, then UK, and then Europe, and then international. The difference between UK and Europe is English speaking and non-English speaking countries. International and world. Oh yeah, world contains every single country. International means the countries that are not US, UK, Europe, non-Europe. The four columns. So every rest of basically the rest of the world. Let's call it rest of the world. ROW. Rest of the world. Good. Created. No. What's the? Where are you guys stuck? What's the hold up? Yeah. You're getting an error. What's the error? Right. This is your error. What's the error? What is it? 1050. So it looks like your database or table already is there. Yeah, you already made a table. It's probably from the previous exercise. But did you create it? You should be creating a database, and then within the database, there should be a table. So you should not have a conflict. All right. So so the next part I'm going to show you how to import this data. But before that, I need to create this database and table. So I'm going to create one, and then you guys can see if that's what you have as well. So the first thing going to create a database. So create database, and I'm going to call it music underscore db. All right, and successful. All right, let's refresh. Okay, so my music database is there. The next one, I'm going to create a table. Create table, and I'm going to simply call it songs. Okay. Let's see. My first column is a number that goes from, looks like from 1 to 5,000. Okay. So a simple integer column, I'm going to call it position. All right. It's going to be integer, and it is not going to be null. Okay. So there should be a value for every single row. All right. My second column is going to be the name of the artist. So let's call it singer or artist, whatever you want to call it. It's going to be simple varchar. And then I'm going to do it 100. Okay. Let's see. My third column is going to be name of the song. So let's say song varchar 100. All right. The third column is year. So year. Let's say this is going to be integer as well. Okay. And then these are all the scores, popularity scores. So let's go ahead and create those. Worldwide total. So let's say popularity pop score total. Let's say pop total. Okay. What is the data type that you guys use for this one? Excellent. And then what's the 5.3? That's pretty good. Yeah, I would have the same thing. Can this be not null? Would this be okay for this column or not? No, and the reason is you will see some zeros over here. That's what I was saying, that this viewer is kind of formatting it. But basically, if you look at your CSV file, these are like empty values. They don't exist over here. Okay, so these are basically nulls. So it looks like our scores can have nulls in it. So that's why it's better not to have not null. They can have nulls in it. Basically, you're saying it can be null. Okay. The next one was pop, let's say USA. Same thing. So all of them are 5.3. Is that what you guys have? Let's say, okay, pop, and then was UK. Same thing. So I have total USA, UK, Europe. So underscore Europe. Yes.
Are you required to know?
I know by default it can have null. I was just indicating that this can have nulls in it.
So
Yeah.
that doesn't like require it to be null or anything like
No, it is indicating that this column can have nulls in it. Yes. Yeah. Yeah. If it requires null, then I can't basically put anything. No. It not null says this column cannot have null. By default, it can have null. So I'm just putting it so that you guys know that this column is going to have nulls.
Okay.
Yeah. All right. Let's see. The last one was basically rest of the world. So I will just abbreviate to row. Okay. Now I have my columns. All right, but I don't have my primary key. What did you guys choose as primary key? Position. Okay. There's no need to have an auto-generated ID. Again, why? This is the data set that we have. And from this, we can easily see that the first column is unique, right? It goes from 1 to 5,000, not repeatable. So you don't have to create a separate ID for it. You can use an existing column as an ID. Okay, if this column is going to be an ID, it cannot be null. So that's why I have not null over here. Okay, is that clear? All right, so this is what we do. You will be given a data set, and how do you come up with a table from that data set? Okay, and this is looks if this is everything is good and we are able to create it. My data set should be able to import into this table successfully, and we'll do it when we do an import. Let's go ahead and run this. Music database. Let me select it. Run it. Successful. And songs, columns, and these are my columns. Okay, looks good. All right, any questions? Does everybody have the schema for their table? If you don't, the next part is not going to work. So everybody has the schema. Names doesn't matter. The more important is you have the data types, you have the primary key, they kind of match with the data set. Okay, so now going back, remember I said that you have two data sets. One is called top songs and one is called 5,000. Oh, one is called 1,000. So this means the first data set has only 1,000 rows. The second data set without any number has 5,000 rows. Okay. Um, if you try to import 5,000 and you see that your MySQL got frozen up, it's not working or something, kill it and then try 1,000. Okay. Depending on your laptop configuration, what happens is some people are not able to load all the 5,000 rows. That's why it's given over there. But I have tested. I'm going to import 5,000. It should work fine on mine. Okay. All right. Now, how do we import all these rows? You are going to select your table, right? We are trying to import this data set into a table, right? So that's why I'm going to select a table. If you right click this table, you will see an option called table data import wizard. Okay, what does it mean? Import means you can bring a data set into this table. The export means if this table has data, you can bring it out, put it in a CSV file or a Excel file or whatever you want. Okay, right now we are trying to bring in data into this table, so that's why you're going to use import wizard. Okay, again, select the table, right click, and then click on data import wizard, it says. Okay, the next screen you will see is what is the file that you want to import. Go ahead and browse through and pick either the top songs 1000 CSV or top songs. Okay, so I'm going to browse and then I'm going to pick this one, day 3. I'm going to pick this one. So this has 5,000 rows. I'm going to go ahead, open this. All right, do a next. When you do a next, it's going to ask you if this is the correct table that you want this data in. Okay, we already created a table. That's why by default the first one is selected, and that's fine. Okay, so it says use existing table. It says music underscore db dot songs. This means the first is my database name, which is music underscore db, which is correct. And then within the database, I have a table called songs, which is also correct. So I won't change anything over here. Okay, I'm going to press next. All right, the next part, it's mapping. It's taking an intelligent guess and it's mapping the data set to the columns in your table. Okay, it's pretty good and it's pretty accurate, but let's make sure that it looks good. So you see two columns. It says the source column and the destination column. All right, the source column has the data set. So it is saying it is giving you the first row over here, and it's saying the first row, the first column is 1. I'm going to import everything over here into the position, the column called position. Is that good? Yeah, that's what I wanted. The second is artist. That's also good. Song, year, pop total, USA, UK, Europe, row. Everything looks good. Okay. If it is a mismatch, you can click this drop down and select a different row. Okay, it gives you options before it imports everything. Okay, if you created your table correctly, if you did this, everything by default should work. All right, you shouldn't be able to, you shouldn't have to change any of the default settings. It's pretty good and making a pretty correct guess. Okay, any questions? All right, and then you will click next and it's going to start importing. It says prepare import. These are the two steps that it's going to take, and this is the one that's going to take more or less time depending on your MySQL installation and computer. Okay, so these are 5,000 rows. For me, it should take less than maybe like 20 seconds. Okay, again, I want everybody to complete this step because we are going to run queries on our data set. Okay. All right, so my import is complete. Anybody, you guys are good? Okay. How many people were able to import successfully? Okay, awesome. What about the rest of you guys? You're good? Michael, you're good? What's the trouble? All right, David will take a look at it. Jeremy, you're good? What are you getting? Did you click your table over here? Right click? No.
The outside. The outside. I don't know. They're right because these are all the streets. People pushing the car.
Yeah, so it's basically telling you that, okay, you know, like in JavaScript, you have the documentation, you can change stuff. Say it's not bad, it doesn't change the database.
Yeah, well. Sure.
And now we can check the columns.
I did get a guinea pig.
So this is basically this is the first row of the data that's coming in. And it's gonna tell you, okay, I'm gonna put this value in this information, this value in that. We basically see. And if you scroll down, you will see.
It reminds me much of cherry, red. Cherry I can do. Grape is just a weird thing. It triggers a reaction. Not as a kid. Oh yeah, it has those.
So yeah, so we just need
Let's break into it when they start softening. No, it's got that part.
No, I'm doing it on my one.
All right, so if you click next, it should say how many records were included. If everything is good, you should have 5,000. If not, it's okay. It's probably, I don't know, maybe the table definition, or what you can do is you can give it one more try. Just make sure your definition is good. Don't import it because it's going to create 10,000. So either drop the table and just rerun the query. Make sure your table is good. It should import 5,000 though. Let me check your create table query.
So you guys have street corn? This is okay. Because everybody still has like that kind of like it's like on the top and you put cheese on it. It's like parm, sprinkled cheese, like parmesan.
So when I was
Yeah.
All right, let's do this. We'll take a break because I know it's taking some people time to import the data. We'll take a break. We'll start back at 8 o'clock. During this time, make sure you have all 5,000 rows.
That's like my thing, like
the one now? I put it on the 1,000. We're gonna miss out the 4,000.
What's next time?
Yeah.
Oh, backyard process. I've heard it's good. When you compare it to like the dollar companies, yeah, they just opened a big restaurant just right here. What's Steve? Oh yeah. Oh, they call it. Yeah, Papa no. I think there's like some place like it's called like the Loaded.
Wow.
Yeah.
When I'm ready for the, it only gave me like 4,500 some.
It's good for a taco shop. I gotta say, that is my.
So,
Especially when they start doing Dude, when the Eagles score close, they score 3 or more runs. Get yourself free taco. Yeah. And you like you can go like I've gone before like my kids. Like, well, can I get 6 drinks? How many of your
yeah, it already has that.
Oh, that's not.
Yeah. Oh, yeah. Why would that even last then? There might be some content that's trying to implement and
University.
they can do it, and that's what's good. So let's see, that's one thing.
Yeah, that one's still.
Yeah, importing the data.
I still haven't been. Yeah, I've heard it's really good.
If there's any more.
Oh, yeah.
The ones I like, the ones I like, there's one brown base. Brown base. It's called, it's called
On your computer, whatever. That's hard drive. And hard drive.
There's a place over where
It's not so I don't think depending on the data set. Like right now you have
Could you put in some sort of logic and then just like set this number to be like the maximum record value.
No.
Well, this is hard. Yeah, I know.
I got the mini one. There you go.
That's what I'm saying with words. It's not that. Probably be having like the word.
No, I just sound wrong. They'll offer I wait till they're I try to find the what is it? Yeah, the whole brand.
One of the factors that had full size mini versions. They just have boxes and boxes.
Oh yeah.
I thought about it. I was gonna grab one for half the class, but
Oh, you need to be fresh. Why don't you like it? No time peanut butter? Sarah has peanut butter pretzels. My boss always was sitting in a great table last night. I used to hate those when I told them. And now I'm just
I prefer the dark chocolate one.
But that's, yeah, that's exactly the thing what you have to do. Use your no. getting.
So you just have some.
No, thank you guys. Half of the people, most of the people probably don't. A lot of the times we're going anyways.
Yes. Yes. We're going to be writing some queries on this database.
I like
Yeah,
that.
but don't ask me any questions. I don't know.
You mean like
Still important coffee? Chocolate. Really? I have noticed that it kind of creates this like cement. Like yeah, it's kind of bitter. But there's like certain like one. I spent
Yeah, but that's a problem too, because this is a smart developer. He knows that he's writing with multiple people. He's not writing all those for the computer. So if it's a smart working code, you should be able to.
I want more
Yeah. And then,
I use smart. You can't really do it. Like it's gotta be perfect. I like that.
a lot of people mistake complex code.
Maybe we're drinking black.
There's a lot of people why they don't optimize their code. And even themselves, they usually do it 6 months later and they have no idea what they're doing because they don't remember what they're doing. Don't worry about it. Especially like computer numbers and reactive.
Where do you work?
I work with this composer spring. I work on their website. So our stuff is we have multiple platforms on Rails, backends, and then language
This for now. See ID that is
Jasmine from Aladdin, Minnie Mouse, Black Panther,
Yeah.
And what time does Sugar Creek start? I need it.
what time if they're little ones, if they're little ones,
Like 5.
right.
Like 5, yeah. Okay, well, my husband and mother-in-law are trying to tell me that it starts with 3 and 4. I'm like, you never, people are they're on the bus still. Like, nobody's on the freeway. Yeah, and they were like, no, 3 and 4. I was like, are you rapping live? Like 3 and 4.
We would always make those like
Yeah, no, like really little kids, I think, start around like 5, because they only go to a couple months anyway, when they're really little. But like, other than that, like, dusk. I remember we'd be like, hey, I want to get dark.
even my parents like that. We would try to go early and they'd be like, yeah, no, it's not right.
Yeah. I was like, and I couldn't find like on Google like a definite answer, and I'm like, no, people are stupid. No way. I grew up in the Midwest. Never did I go trick or treating with eighth grade.
Well, I mean, not 3 or 4.
It's snowing right now there. I think I want to go back. Yeah, my sister's pregnant and she can't wait for it to be like, I don't want to live in this place. I don't either, but like I also want like my kids to be around. Yeah. And but we don't have any kids yet, so like it's like in the 5-year. I think I do. Yeah, like I would move back there and make lots of money. Well, what I'm hoping, I mean, I don't know. I want to get like a job remote and get experience and then move. Like I'll have a job that way we're only looking for one job. And then actually like GM, I have a lot of software and I mean, I would need experience. Like there's no way I could do one like but after like my friend worked there. Everything is games are yeah. But that's amazing. That's just like it's harder for me to like get into like I don't know. I think I want to do back end. I feel like we won't know until we actually like start getting into it. But you probably have a little exposure. More like talking to people. Yeah. Yeah, that's why I feel like working on my life is hard. Then I don't know anymore out here. I feel like I was from experience. Yeah,
He was full-time kid and now he works
I just, I mean, I haven't even really, I mean, I have it far. I haven't like, really, I've looked at a few like, I was talking to my friend yesterday who works at GS and I'm like, if I can find it and then grab a family and move like, but then I was just, like the union for the not all of them, but like more of part of the union. They were, I don't know if it's long, but there are benefits.
All right. Before we begin, if you are using the 5,000 one and it gives you anything less than 5,000, it's probably something wrong in your schema, right? And I've checked with everybody who was getting less, and there was something wrong in the schema. If you have a schema defined too short, for example, your varchar column, instead of 100, you said 30 or something, and it MySQL encounters a column which is more than 30, it's just going to skip it, right? It's not going to get, it shows an error, but I mean, if you look at the logs, it's just going to skip that column and move on to the next one, okay? If your decimal 5-3 is different, it's going to skip that. If you have not null in a column which has null, it's going to skip that, okay? So if you have your schema correct, you should see exactly 5,000 rows being imported. Okay, or 1000 if you were using the 1001, depending on which one you use. You should be able to import every single row if your schema is correct according to the data set. All right, most of the issues that I saw were people had this as less, like 30, and some of the characters more. Somebody had a not null over here, and some of these columns are going to be null. So if you put it as not null and it's a null, it's going to skip. Okay, and if you have imported, just run your select query, and then ensure that everything shows up. So I'm going to say select star from songs, and I have all my rows over here. And then if you see at the bottom on your action tab, you should see it says 5,000 rows returned. So this means I'm getting all my rows back here. Okay, 5,000 rows inserted. And this is how my data looks like. Let me go ahead and close this. All right, any questions before we move on? Does everybody have the data set? Because we're going to be writing queries on this data set now. Yes, oh, sorry, yeah.
Mine imported 5,000, but is there like a setting that I have to change?
Yeah, I think it says on the top, it says limited. I have set it to don't limit to anything.
Oh, okay.
Yeah.
Thank you.
So the data is there, it's just showing you less. Yeah. Yes.
For some reason, two of my stuff came back null for all of them.
Two of your what?
Like two of my,
Columns?
yeah.
So it wasn't able to import or do something. Do you have the def schema correctly? Just like this?
Yeah, well, I don't have the null.
Yeah, that should be okay. But everything, this is good?
I just put 40.
You did what?
I put, instead of 100, I just put 40 for like the artist and stuff.
Right. So if the artist is more than 40 characters and we have determined there are some names that are more, so that it's going to skip right over. 30 didn't skip? You got 5,000? With 30? Both of these 30 or just the artist?
I did both mine 20 and it worked.
It worked?
Both of mine are 30, yeah.
Oh, okay. All right. Well, I saw some people who 30 wasn't working. That's interesting.
I didn't read all 5,000, but.
Oh, no. It didn't read all 5,000?
No, I meant like visually, I didn't read them all, but I
Oh, no.
all names were less than 20,000.
Yeah, but if you run your query, it says 5,000 rows returned. Like if I run this at the bottom, it says 5,000 rows.
Oh, wait, no, mine's saying 3,000.
Right. So, and the reason is because you have this as less and it skipped. That's what I'm saying. It's going to skip anything that does not match the schema. So your schema is 30. So it's going to skip over all those.
Should I delete it and stick it in there?
It just
You don't get to go.
yeah, it just says you don't need to go.
I thought it would just like cut it off or whatever.
No, yeah, cut it off is over here because you're importing, so it's looking for exact match.
So I do see it in my like rankings, they're missing.
Yes.
So
So
I'm missing. Should I redo it?
I
just go all the time.
okay. So before you redo it, hold on. Let me introduce the new exercise, and then so everybody is on the same page. But you have the data set. It's just the schema is not correct. Okay. All right. So we are going to go to activity number whatever the next one is. This is the coding part. Okay. So now we have the data set. Now we are going to write some queries and we are going to write some JavaScript code and pull that data into a Node.js app. Okay? All right, before you start coding, what I would suggest is these are the 4 queries that you have to write in your JavaScript code. Okay? So basically just like your Grade Bay app, you have to create a prompt, you have to make a connection from your Node.js and then write some select queries and get data that kind of falls into these categories. Okay. The first one is write a query which returns all data for songs sung by a specific artist. Okay. Even before you start writing the Node.js code, I would recommend write the query in your MySQL over here. Once that is good, it returns the data what is required, then go ahead and start on your Node.js app. Okay. Let me do this one more time. So eventually you have to create a Node.js app that is going to run this query, is going to get all this data. Okay. The first query is write a query which returns all data for songs sung by a specific artist. What does this mean? That I'm looking for songs from this data from my database, okay, by a specific artist. For now, you can pick any one and then write that query. Okay, eventually when you go into Node.js, you're going to take that as a user input. The user is going to say, hey, I want to see the data by Eminem or Madonna or somebody over here. Okay, but the query is still going to be the same. All right. Yes. Question?
Oh no, I was just excited him to make.
Oh, okay. All right. The second query is, which you're going to write, a query which returns all artists who appear within top 5,000 more than once, or top 1,000, whichever data set you used. Okay. So this query, you have to return the names of all the artists that have made the chart more than once. And it is there. If you look at over here, let's see if Hanson is there more than once. Probably not. Probably not. All right, let's see.
Probably the Beatles.
Yeah, Beatles is there because I ran the query. Okay, for example, Beatles. If you see, Beatles are going to be here. It's there. I am just going back again, so that's why it might be the same Hanson. We'll see. Eminem is there multiple times. So basically, you're trying to find from all this data set all the artists that are in the chart more than once. Okay, that's the second query. This query is probably the most challenging one, so I would do this one as last. The first one is easy, so try that first one. The first and the last one are pretty easy compared to all these four. The last one is a query which searches for a specific song. The first one you search by specific artist. The last one says search for a specific song. Queries are going to be very similar, the first and the last one. All right. The third one is after that. Do the third one after this. A query which returns all the data contained within a specific range. Okay. Now, what range it hasn't specified, right? I would say pick, let's say, pick position. So I want to find all the artists, all the data between position number 40 and 100. So it should give me 60 rows starting from 40, position number 40 up to 100. Okay, that's what this query is saying. A query which returns all the data contained within a specific range, right? It does not define which column, so you can pick any column. The easiest column would be either pick position, you can pick year also, any number column, that's easy. So basically you can say I'm trying to find the songs data between the years 2010 to 2019. Okay, that's what this one is saying. So either pick a year or pick a position. But basically the third query is saying you need to return, instead of all 5,000, give me a specific range of data. Okay, and then the last one, the second one, this is probably the most challenging one. You have to find an artist which is present more than once from the list. Okay. Now, first and the last, you should be able to do it with whatever we have studied. Second and third, you have to a little bit do some research. I'll go over the queries, but you will have to do a little bit research on the second and the third one. There are different keywords that you have to use to complete second and third.
So you can do it just with MySQL.
Oh, all of them you're going to do with MySQL. Yeah. What's the other option? What do you mean?
Well, if it's in JavaScript.
But still, it's the same query. You're going to write the query and going to copy it over. Yes. Do you see what I
I
mean?
guess it's whenever you can't do it with just query.
What?
The second one.
The second one, you can do it just with query.
Oh.
Yeah. No. Now I see what he means. These all are going to be queries, SQL queries. No.
No JavaScript.
Right, but you get my point? Okay, I don't want to confuse anybody else. So like no array parsing, no object, nothing of those. You are going to write these queries in MySQL first. Make sure these are good. These are returning the data set that you're looking for. And then you're going to write a Node.js app using the connection and everything and bring that data over here. But the more important is you're able to write these queries first in MySQL and then jump onto the Node.js part. Is that clear? Any confusion? Does everybody understand what they have to do? Okay, let's do the first step. Write these in MySQL. Again, the first and the last are the easiest, and whatever we have studied, you should be able to do the first and the last. After that, attempt number 3, but you have to Google something and see how do you find that range, and then try to see if you can figure out number 2. Let's go ahead and change this order so that, oh, I have to change it over here. All right. Where is it? So let's do this. So the first one, then second, and then let's do the last one as number 3. Okay. All right, let's follow this order. Okay. So start from the top, and right now we are just writing MySQL queries in MySQL. Okay. And then once you have this down, then you're going to move it to your Node.js. Yes. So anybody completed the first query? A query which returns all data for songs sung by a specific artist. 2, 3, 4, 5, 6. Okay, got it. Okay. So what's the query? Anyway, yeah, go ahead. Select. Right. Simple. Select. If you do a star, it returns you all the columns. Might be better to pick few of them so that the result set is condensed. Right. So for what I mean is, let's say what are my columns? I'm going to skip the popularity. So all I need is, let's say, position, artist, song, year. Those are more relevant. These are numbers that are there, but they don't really make sense to me. So I'm going to skip all of those. This is the first query. So basically you're saying select, let's say position. What was, let me look at my schema. Forgetting. Position, artist, song, year. Okay. These 4 columns from table name song. Okay. Oops, song. Where artist is equal to some artist. Right. Let's say the Beatles. And then, oops. There's something wrong. Let's see. Table music dot does not exist. What? Songs. I have a typo here. Okay. So you see how many rows returned? 44. Instead of 5,000, I'm getting 44. Why? Because I searched by artist, and this is what it shows. Okay. So that's your first query. Query which returns all the data by a specific artist. The second one is similar to that. Anybody complete the second one? Yeah. So what's the difference between the first and the second? Right? You're pulling by the song. Okay, I'm going to keep this over here a few more minutes and then we are going to move on to the third and the fourth. Questions, let me know. The first two, at least everybody should be familiar with. The first two queries. The range. The second one is just by the song. I switched the order. Which one are you talking about? Oh yeah, more than once. Yeah, were you able to solve this one? Okay. Yeah, we'll come back to it. So I changed the order. These are from easy to the most challenging one. Yeah, the second and the first are similar. There's the different columns. Third, if you are done with the first, you look at the third one. It's something new, but it's not as challenging. It's just one word that you will find it, and it should take care of the query. Did you find it, Chris?
Well, I'm looking at the fourth one.
Oh, okay. Did you see? What about this one? Third one.
I didn't see that one.
Oh, okay. Do the third one. That's a little bit easier versus that one. All right, any question on the first two? Is everyone able to do the first two? Basim, you look confused. Oh, third one, yeah. What about the first two? Did you get the first two? You have a question? Yeah, go ahead. And okay, okay. This is going to be a table name. Is this your table name? Is called title? Right. So from this is table name and this is my column name. So yeah, that error kind of tells me it's looking for a table called title. All right. So no questions on the first two. Still good? Okay. Anybody did the third one? Ooh, what did you guys use? Yeah. Between? Okay. Anybody else use anything other than between? Yeah. There's another choice, but between is probably the easiest one. I would use between too. What did you use? What is it? Chris is going to tell. Chris, what did you use?
Where the column is greater than and column is less
Yeah. So instead of between, he used pure vanilla MySQL basic. Yeah. So he used the greater than and the less than one. What did he use, Bruce? Okay. You did the last one? You got it? Ah. Wow. Man, that's the fastest anybody in my any cohort has gotten. Seriously, I've actually had to solve the last one. Ah, good job. Yeah. What did you use?
Select artist, count artist from song, group by artist, having count artist greater than
Yep. Okay, so let me do the third one. You can use between or greater than and less than depending on what you're trying to do. For example, let's do year. So select position, position, artist, song, year. Okay, from songs. Oops. From songs. If I do the year, you will say where year is between, let's say 2010 and 2013. Okay, so this should give me all the songs between this, and this gives me all the songs. Okay, between those two, between the years. The only thing is, it's, you see the years are not sorted. Did anybody was able to sort this? Okay, if you want to sort, there's no sort method per se. It's called order by. So you can say order by and the column name. For example, I want to order by, I want to sort by year, and then by default there's going to sort by ascending. ASC means ascending. You can skip this. By default, that's what it does. Okay, so if I run this, it has sorted. It got the result set and then sorted by year. Okay. By default, it is ascending. If you want descending, it is DESC. So ascending, descending, both of them will work. This time, the latest one is on the top. Okay, and then you can sort by position or whichever number you want. but for sorting it's called order by. Okay. Any questions on the third one? You can do by position. So let's say if I want to change, I want to see between position out of my 5,000. Let's say what is between position 40 and 50, and then I'm going to still no. This time let's sort by position. Let's do ascending. So no need. So we'll sort this now. So these are. It should give me 10 results, and these are the between people, the artists between position number 40 and 50, and you will note that it is inclusive. Okay, it's going to give you 40, the starting position also, and the last one out as well. Okay, so I had 40 and 50. This means between is inclusive. That's what we call. Okay, this means it's going to give you the number 40 also, and this one also. So basically, it's greater than, equal to, less than, equal to. If you just use greater than, it's going to skip 40. If you use less than, it's going to skip 50, but you have to use greater than, equal to, or less than, equal to. Okay, any questions on the third one? Make sense? All right, so I know one solved the fourth one. Anybody else? Chris solved it. 3. Okay, got it. You guys all use group by and having? Okay. So let's look at the fourth one. So fourth one says you want to return all the artists who appear within the top 5,000 more than once. Okay. So there is a keyword called group by. What it does is it's going to group your data set into it's going to actually reduce your data set. So let's suppose you have 5,000 rows and you want to reduce your data set. You want to group that data set by something, by some column. For example, you want to group by artist, right? The artist, you saw it in the data set more than once the same artist is appearing, right? For example, the Beatles are there how many times now? If you have the query. Groups how many times? 24? 44 times. Okay? So what group by does is going to collect all those 44 rows and bundle into one. Right? If you say, hey, group by artist, is going to take all the similar artists, all the rows that have the same artist name, and kind of group them together. So your result set of 5,000, if they're repeatable artists, is going to group them together and say, oh, these are the unique artists in your data set. That's what group by does. It actually groups them by some criteria. And what is the criteria? It's the column name. Okay. For example, let's go ahead and write the group by query. I'll say select position, artist, song, and year. Okay, from songs. Okay, and then I'm going to group the data set by one of the columns. So I'm going to group by artist. Okay. Now here's the thing when you're using group by. If you run this query, it's going to give you an error. If I run this, it's going to give you an error at the bottom. Okay. So the problem with this query is the column that you're trying to group by, that's the only column you can see also. You cannot see any other column. Right now, what am I trying to do? I'm trying to see column position. I'm trying to see column song. I'm trying to see column year. But I'm trying to group them by artist. You cannot do it. It's a 1-to-1 ratio. If you're trying to group by artist, you can only see the data for one column. So you have to say this thing. Okay? If you're trying to group by, well, position is unique, so you really can't group by position. It won't do anything. You're trying to group by, well, song is also unique. Year might be something you can group by. So if I want to group by year, I can only have the year column over here. Okay? I can group by multiple columns. Then you can put any column over there. But then it kind of changes into something different. So let's check this one out first. So that's a restriction if you're using group by and you mention the column, that's the only column that you can mention in your select statement over here. Okay, you cannot have any extra columns. Now if you run this, how many rows did it show up? If you look at the bottom, it says out of 5,000, it shows 2,287. This means around 3,000 are kind of recurring. The same artists are coming back again and again. Okay, so these are the unique artists in my database. What it did, it grouped all the rows together which had the same artist name, right? And the result set was 2,287 rows. That's what group by does. It is going to reduce your data set. It combines the data set based on some unique values. For example, what am I trying to do? I'm saying, hey, whatever the artist names are, reduce the data set using the artist. So if the Beatle occurs 44 times, it's going to reduce them to just one row. Okay, so that's why you will see less than 5,000 rows kind of showing up. But I don't want to say drawback, but the only thing is you can only see the column that you're trying to group by. So I can only see the artist. Okay, and these are going to be unique, right? Because if they were not unique, they have been grouped by together. So the artist name that you see are not going to occur anywhere else within this data set. Go back here. Okay. Any questions on group by? Right. What does group by do? It kind of groups your data set based on something common. So if my artist is happening more than once, it's going to group them together. For example, the Beatles are happening 44 times, groups them together, reduces all the 44 rows into one. Okay. Now, these are all queries. I just want you to know your original data set is always going to be there. Does that everybody understand? If I run my select start from songs, I still get 5,000 rows because my data set, my physical data set will always be there until I run a delete query. Okay? I'm just selecting, basically I'm filtering out my data based on the select queries. Okay? So your data set of 5,000 will always be there until you go ahead and delete them. Okay? Select queries are used for filtering some kind of queries. So this is how it goes, that you will be given you will be given a statement, a sentence, an English sentence, and then you have to convert this into a query, right? For example, the third one, select something between this specific range. This question is in English, but you converted this into SQL query, and this is what you have to do. Okay, this is how some of the interview questions go regarding the database part. Okay, now, all right, any questions on group by? Kind of get the concept? Okay, now what can I do? I cannot put any columns that exist in my group by, but what can I do? There are some functions that exist in MySQL. Those are called aggregate functions. Okay, what they do is they do some operations on your column, right? One of them is called count, right? The function, it's actually a function, and if you type in count, it should show up over here, this thing, the second one. Okay, what does count do? It is going to count the number of rows that this select is returning. Okay, this group by is returning. Okay, and this count is going to give you that number, right? Again, what it happens, you're going to group by artist. For example, Beatles are in the database 44 times. Okay, so what this is going to do is going to group by Beatles, and then this count statement is going to give you a new column with the number of times that artist is in your database. Okay, again, count is a function part of MySQL, and basically star is saying, hey, go ahead and count everything which you are grouping by. Let me run this so that you guys can see, and then I will kind of come back to it. Okay, so if you see artist name and account, so this means this artist is present in my database of 5,000 rows 27 times. This is 3, 2, 1, 44, 8, 18. Let's go ahead. Oops. Okay, let me see. So right now what happens is if you see the column name, it says count parentheses star. If you want to rename this to something, you can rename this and say as what do you guys want to call? What's a good name for this? Let's say simple count. You can come back and change this. So now the column name is count. Okay, it just renames the column. And then I want to see if this works. If I want to order by count, let's see if this works. Okay, it does. Okay, so if you see these are all occurring one time, one. Okay, and then all these artists are there in my database 6 times, 7 times, 8, 9, 10, 44, and 49. Okay, that's what count does. Kind of shows you how many times this column is appearing in your database. Okay, count usually goes with the group by. That's what we need. Again, the problem with this group by is you cannot put any column that is in your database unless you put it over here as well. Okay, but you can put as many aggregate functions you want, and group by kind of does not worry about that. Okay, the only drawback, the only restriction is you cannot put a column name that is not present in your group by. Okay, the group by column should match the column in your select. Okay, so I use group by count and then I ordered by count so that we can see in ascending order or descending order, doesn't matter. Let's see. So the Beatles are 44, Elvis Presley 44, 49 Madonna, Rolling Stones. So these are all the number of times this artist is appearing. Yes. What is the what? It's the sort order. So order by is used for sorting your data set. Okay, so I'm saying sort by this column count in descending order. And if I do ascending, then the first would be number 1. Okay, so let's remove this. So what was the query? The query was that I want to get people who are here more than once, basically starting from 2. So it should skip all these ones over here. Okay, now remember this where clause. When you're using a select query, you have where clause, and where clause mentions a condition, right? Similar to that, when you have group by, you have also a condition, but it's not called where, it's called having. Okay, so it's the function is same as where clause. Like for example, for the select one, you are saying where you are putting a condition over here. Okay, now in our example, what do we have to do? We have a condition where the count is greater than 1, basically, right? It's occurring more than once, right? I have to put that condition. The condition goes by group by. I cannot use a where clause. Group by does not recognize where, so instead of that, it's called having. Same purpose as where clause, but where clause works with the select statement. Having does the same function, works with the group by. Okay, so example, you would say select this, where the position is between this and this. You would say select this from this group by this, having count is greater than 1. Or you could say count between 10 and 40. You can use anything. It serves the same purpose as the where clause. The only difference is where clause goes with the select, having goes with group by. Okay, so if you want to put a condition with your group by, you're going to use having instead of where. Okay, so now if you run this, it should give you all the artists more than 1. Okay, or you can put a condition, say give me artists more than 30. So only 4. Okay, you can use a between 10 and 30. That's going to give you more. And all of those conditions will work. The same condition that you use in the where clause, they will work over here. Okay. Again, the only difference is where clause is tied with the select. Having is tied with group by. Okay, if you want to put a condition to your group by, you're going to use the having clause. Okay, so if you go back to this one, it says a query which returns all the artists who appear within the top 5,000 or 1,000 more than once. So I'm trying to find all the artists that have a count more than one. All right, any questions? All right. Even if it is real confusing, please make note of these keywords: group by, order by, having and group by go together. So if you are looking at the documentation from group by or any tutorial, you will see having as well. But group by, between, and order by, and these are like widely used, right? You will see queries which use this a lot. Okay, again, you see the advantage. There's a big data set, but you need to restrict it. You need to find certain amount of data, and that's why group by, order by is for sorting, but group by is used a lot. Having, order by, between is also kind of used. Okay, questions? No questions? Everybody understood group by? Okay. Even if you understand right now, please go back and make sure you review these things: group by, order by, having. Every time I have to look at it, I have to go back, look at the documentation. It's faster every single time, but I still have to look at it. And oh, is group by the same as order by? Kind of get confusing. So make sure you read up on this again as well. Okay. All right. Let's look at next thing. Again, the exercise says you have to write the Node.js code. I'm going to leave that up to you guys. Make sure you do that part as well after the class. But basically, these are the queries that you're going to copy and bring it over to your Node.js and run it, and it's going to give you the data set. The same data set that you see over here, it should print out in your Node.js app. Okay? All right. Anything else? No? Okay. All right. So the one thing I want, well, there's a couple of things. Let me show you which query. The first one, where the artist is. Okay, let me do this. I'm going to pick one song, then I'm going to write the query for the second part as well. Let's just select position, artist, song, year, from songs where song is equal to this thing. Okay, comes up here. Let's see if I can show you guys this thing. Okay. All right, so we are going to kind of concentrate on this query, this one. It's a simple query, the same one, this one, the song one. And what it does is it goes and fetches a song. Okay. Now, when we have a large data set, right now it's 5,000. It's still not as large. I'm talking like million rows or something. So what happens is these queries kind of become slower. Okay. And the reason is what is it doing? It's going to go ahead. How does the search? It goes into your data set and starts from the top and then keeps going down, down, down and looking for this song. Okay. If this song is the last one on your data set, it's going to go through all 4,999 and then find this song. Okay. Does it make sense? All right. It goes through each one and finds it, right? So in your bottom where you see the queries that gives you some activity over here, oh, that didn't help. If you run this query and you will see a fetch time over here. Okay. The second after the forward slash 0.00. How many zeros are there? 4 zeros and 14. So this is how much time it took to find this song from this data set. Okay, I know it looks really small, but when it comes to a computer, every millisecond kind of counts, and the more time it takes, it's a bad thing. All right, this is the time you're spending to get the data and then send it to your UI. Okay, so when you have a lot more rows, what we want to do is we want to speed up this fetch time. We want to make this fetch time as minimum as possible. Right, to do that, there's a concept called index in any database. Okay, it's called index. What index means, you're going to index your data. Oh my, Google is searching for everything I'm saying. No, what is all right, so what it does is you can index your data. What it does is it's going to sort your data and keep it aside. All right, you're going to tell the data, hey, before even I make my query, my search, create an index all the data set from this column. What basically it does is going to sort it out and keep it somewhere in the memory or on the hard drive. It doesn't matter to us. It's going to make an index for it. It's kind of going to sort it, right? Once this data set is sorted, the fetch time is much easier. Okay, when you try to search something, what it does is, if it is sorted, it can use binary search or some good sorting algorithm, so kind of get to this point extremely fast. Versus if the data is not sorted, then there's no pattern, right? You don't know if this is going to appear on the first or on the last. Is it greater than this one? Is it greater than this one or not? It's confusing, right? So what index does is it sorts your data and keeps it aside. And when you make a query, it's faster. The fetch time is a lot less if the data is sorted versus the data is unsorted. Okay? Does everybody understand this concept? That it's always going to be faster to search something if it is sorted versus it is unsorted. Okay? Because there are sorting algorithms that are super fast, but they only work if the data is actually sorted. If it is not, then they cannot make a pattern, they cannot determine where the data set actually lies. Okay? So for that, in databases, you will hear the word index, and you tie an index to a column. For example, we are trying to search by song. So it would be more appropriate to create an index on the song column, because that's what I'm searching by. If I'm searching by artist, you're going to create an index on artist. All right. And how do we determine that? It's based on what's the most query that you're going to be using in your program. Let's suppose in my program, in my project, I'm going to be using this a lot. There'll be a lot of searches based on the song name. Okay. So if I know that my queries are going to be based on this column a lot, this is where I'm going to add an index so that I can speed up that fetch time. Okay. Now, how do I add that index? Those are again some SQL queries, and I'll go through them in a minute. But before that, do you guys understand the concept of index? Okay. Again, basically indexes are used to speed up the query, and indexes are based on columns. Okay. You can designate saying, hey, create an index on this column, create an index on this column, right? So you can create an index on every single column. Yes, you can. Is it going to speed up? It's not. Why? Because now every column is indexed, and when you're trying to make a query, there are too many indexes. Okay, so what we do is we only index the columns that we think are going to be used a lot. Okay, any questions so far? Good. All right, the second thing, your primary key by default is always indexed. Okay, any column that you designate as a primary key, that will always be indexed. So anything that you search by your primary key is always going to be a lot faster than any other column that is not indexed. Okay, and then you don't have to create an index on your primary key. Just designating it as a primary key will create an index by default. Okay, so all your primary keys are already indexed. Is that clear? Okay, so those are already sorted, those are already indexed and kept in your database. All right, so any column that you designate as primary key is going to be indexed. Okay, so let's suppose I want to create an index on this one. The queries are kind of they're not too bad. So um, to create an index on a column, you have to do it when you are creating a table, right? When you run your schema file, when you create a table, do I still have my thing over here? Yeah. So in this, when you're trying to create a table, that's where you designate and you say, oh, this column is going to be indexed, okay? But since we already have our table created, I'm not going to drop, I'm going to alter my table and add an index, and then I'll show you how to add in your create table as well. Okay, so since this table already exists, I'm going to use the alter command. Remember from Saturday, I showed you some of the alter commands in W3 schools. So this time we're going to use alter table. Okay, and which table am I altering? Songs. Okay, what am I doing? I'm adding a, oops, add index and then the index name. So let's call it song underscore index so that you can see the differentiation. Okay, again, this is the name of the index that you're creating. Okay, and then the column that you're trying to create the index on, I'm trying to create an index on the column song. Okay, add index, this is going to be your index name. Parentheses, within the parentheses, the column name that is going to have that index. Okay, all right. So if I run this and this is successful, all right, so at the bottom I see my index has been created, okay, which is called on songs. I'll show you how to verify how to see those indexes. Let me go ahead and first run this. Oh, that didn't do anything. Did I search the right one? Let's see. Songs index. Let's go back here. Let's see what indexes are on our table. So show index from songs. Okay, let's see. So I have two indexes. You see the primary key. So by default, it creates an index on this one. And then the second index is the one that I just created. So I have two indexes on my database. All right. If you want to delete that index that already exists, command is drop index. Okay. The name of the index that you get is going to be song underscore index, and then on the table name. Okay. If you want to delete a certain index, you cannot delete the primary one. Drop index, the name of the index that you created, and the table name. Okay. So let's go ahead and run this, and then see my index has been deleted. So index doesn't exist. Okay. Let's go back here one more time. It should show. Oh. Okay, the database is kind of acting slow. All right. So let me show you the difference. So right now, if you see, I don't have any index, and it says this is the, I don't know if you can see it, but it's like 4 zeros and 14 seconds. Let's go ahead and add an index, and you can do the follow along and see the time it comes back. Index has been created. Show indexes. Okay, two indexes, and now if you run this query, for some reason my index is not, it's taking 2 times to fix it. Let's see. Okay, what am I doing wrong? Because as soon as I remove my index, that's when it takes into account. So something is happening to my SQL. Let me just restart this. So if you guys are trying it, what you should see is you should see a reduction of time when you do the fetch time. It's it looks difficult to see, but you will see it adds a lot of zeros in it. So if I run this again, um, Do you guys see it? Somebody. Mm, mm, Show indexes. Okay. And let's search this one again. Oh, you know, maybe this song I picked is. Let me try this one. It's probably already on the top or something. Let's try this one. Okay. And let's go back, add an index. Okay. Index has been added. Let's search this one. Oh, that's better. Okay. With again, I don't know, I won't be able to zoom this, but if you see, this time on this row, this is without the index. It's 4 zeros and 11. With the index, it's actually 5 zeros and 69. Okay. So the fetch is always going to be faster once you put an index. I think the previous one, the song was already on the top, so it just picks it up. That's why I won't be able to see a difference. But that's what the index does. Okay. Now going back again, if you want to add an index to a table that already is created, you will use the alter table, add an index. But if you want to add, when you're creating your table, then just put the index keyword after this. So basically you're going to say primary key, comma, and then you will say create an index on column song. That's all. Okay. If you're trying to create, usually you will see that indexes are created when you are creating a table. What you have to do is just use a keyword index and then put the song name. Put the column that you're trying to index. Okay, but in our case, we already have created this table. Unless you go ahead and drop it and do it, what you can do is you can use the alter command. From remember I was showing you the documentation. You can say alter table songs, add an index, index name, column. Okay, show index will show you all the indexes that are on your table. If you want to delete an index, you would say drop index. Okay, again, indexes kind of add or sorting to the columns and make your queries run faster. Okay, so if there's a column that you think is going to be queried a lot, you would add an index. Any questions? Okay, other than the syntax, does everybody understand the concept for indexes, why they are used? Okay, all right. I'll keep this, just make a note of this, and you can try this syntax, it works. But make sure you understand the concept of indexes, why we are using indexes. Okay? All right, let's do last activity. We did these queries for a single table. Now what you're going to do is you're going to run the same queries, different queries. You're going to import another data set, create another table, just repeat the whole exercise. And this time you guys are going to do this on your own. So open exercise number, what is it? What is it? 14? The last one. Okay. So you will see three CSV files. The first songs and top songs, we already did that. Okay. Go ahead and import the albums. Import it into the same database. Create a new table within the same database. So for example, I created a music database. So database already exists. That's okay. Right? To import the top albums, you have to create a new table. Right now I have a table called songs. So I'm going to create a table called albums and then import this file. Should be pretty quickly. It's almost the same definition. Okay, well actually it's exactly the same one. The only thing is the first is position, artist, and this is the album name. Instead of the song name, this is the album name now. Year, popularity scores, exactly the same thing. So use a creation of the previous table, create a table for albums, import this data, and then we'll look at some of the queries. Okay, so this is exercise number 14, somebody said. Yeah, 14, right? All right, so you have three CSV files. We have already done the songs one, right? So we don't have to worry about that. Now you're going to look at the albums, create a table, same thing as you did the songs one. The only difference is it's going to have an album name instead of a song name. And then go ahead and import this. I think there are, let's see how many rows there are. 3,000 rows. Okay. Decimal 5, 3, everything should be the same. So if I go over here, all I have to do is I can copy this, or if you want to write it out, that's also fine. I'm going to just copy this. So copy your schema definition. Okay. Table name is going to be, I'm going to say albums. Position, into artist, this is album now. Okay. Oh no. This is still artist. Let me go back. So artist, the third is going to be album instead of song. So album. Year, total, position, and everything else should be exactly the same. Okay, so let's go ahead and create this. Successful. If I refresh this, oops. No. Okay, so there's my albums. Now what do I have to do? Right click, import. Import. This time I am importing the albums. Albums. Okay. Open. Next. Music db.albums. Yes. Let's make sure. One position, artist, album, year, numbers. Yeah. So is everything good? I should have 3,000 rows in my albums table. Okay, let's see next. And 3,000 rows, okay. Come back here. I'm just going to run some select queries on my album. So select star from albums and 3,000 rows, okay. Alright, did anybody face any issue in this one? Should be fairly quickly. Just copy paste. I think the only column is different is album. Okay, once you have imported, let's see what query are they asking us to write on this one. So this one is going to be using the two tables. This means we have to use our favorite. Let's see. So you have to take these two large data set. One is 5,000 and 3,000. If you did the 1,000, it's going to be 1,000, 3,000. Okay. Combine the data and come up with a method to join them together in order to figure out if a given artist's song and album made it into the charts at the time of their release. Okay. This is what you have to write the query for. Take some time, understand what it is saying, and see if you can come up with a query. Again, we have more than one table. This means we are going to use joins. Okay. Hint, this can be done with just inner join. You don't have to worry about right or left. See if you can write an inner join query with the two tables and come up with a data set that combines artist, song, and album, and see if it made it to their time of their release. So what I would start is look at the data set and see which columns are common between them. So let's see. So let's start from songs. So I have position, artist, and then my albums have so you have to do an inner join. Right. So you have to do an inner join on what is common. Year and what else? Yeah. So those are the two things that you have to do. You're right. So those are the two common things. It's not exactly correct, but that's what we have. Ideally, you should have a album ID to exactly match. You will get a different data set, but given this data set, those are the two columns that you have to do a join on, because those are the only two columns that are actually common. So this is from my albums, and then from my songs. So why can't I use the position? It's what? It's not the same. Excellent. So the position over here is not the same position in my album. So that's why I cannot compare them on the position. So the song could be on position 10, but my album could be on position 20. So that's why there'll be always be a mismatch. Okay. The only two things that you can join on are the artist name. Okay. And then we will assume that the song, well, that's what the song and the album are going to have the same year. So that's why you have to use the year and the artist name. Okay, so create an inner join query on the artist, whatever the artist name and year. See if you can come up with an inner join on those two things. What is it? How do what? Uh, yeah, right. We'll see how to. I mean, again, I've run some queries on it. It's not exactly correct. And the reason is we don't have anything more common. We just need something more common. We won't worry about it. The only point you have to do is if you're able to write inner join query based on the two columns. That's what I'm looking for right now. So if you say select, we'll do the same thing. We'll say now the problem over here is if I say year and if I say position and then I say album, okay? The confusion is I'm going to join the two tables. Which column am I referring to? Am I referring to the albums year column or am I referring to the songs year column? It's ambiguous. Excellent. So that's why to remove that ambiguity, you have to put the table name, which column are you referring to? So let's say you can pick any one. I'm going to say I'm trying to find the album. Did I say albums? Yeah, albums here. I'm trying to find albums position. So the position column from the albums table. This is how you remove the ambiguity. Okay. Album is only in albums table, so I don't have to worry about this one. Let's get some columns from the songs table as well. So let's say songs. Well, oops. Song is only on songs table, right? Yes. So this should give me song. And then let's get the artist from songs table. Okay, so we're going to select the year, position, album name, song name, and the artist. Okay, from albums, and the syntax was inner join, right? So inner join and the second table name, which is song. Okay, this is the same syntax for inner join that we saw on Saturday. It will select name of the columns, right? Why are we putting table names over there? Because the columns have the same name in both tables. So to avoid ambiguity, we are going to tell SQL, hey, get this column from this table. So it's going to show the year from the albums, not from the songs table. Okay. Then comes the table name after from. So from albums, inner join, the second table. So this is how you combine two different tables. Okay. And then the condition. What is the condition? What are the common columns that you're trying to join on? Okay. And we determine it's the name of the artist and the year. So you're going to say on albums dot artist, okay, where this is equal to songs dot artist. Okay, and the second one was and albums dot year, oops, is equal to songs dot year. Okay, so this is how the joining query goes. Join two table names, the first table, the second table, and the condition you're trying to join. The condition usually has something that is common that will give you the right data set. You cannot use position because it will give you the wrong data set, because the album position and the song position can be different. But the artist name, if it matches, this means it's the correct album. The year, we are assuming that the song and the album kind of came in the same year. Okay. Now let's find for a particular artist. So let's say where albums dot artist is equal to, I don't know. Okay, just so that my data set is kind of reduced to just one artist instead of looking at all of them, we'll just pick one. Where this is equal to Eminem and songs.artist is also equal to okay, just so that I can reduce it to one artist instead of looking at all of them. All right, so if I run this, it shows me for one artist the songs and the albums, the year. Let's go ahead and sort by year maybe. So sorting would be order by oops, albums dot year. So this way my year is sorted out. So on this year, this was the position of this album, artist, this year, and it shows me all the years over here. We can also add more sorting. For example, if I do albums dot position, what do you think this is going to do? So I'm ordering by year, and then I also added this column. What does this do? Any idea? What is it? Right. Yes. You heard that? So first is going to sort by year, and then within that year, then it's going to go ahead and sort by position. So what it does is it sorts by year. So within the 2000 is going, if they were different, it's going to sort them. So for 2002, it's sorted by 2002 first, and then the second was position. So within that is going to sort by 34, 34, 247, 247. Right? Or you can switch it around and say descending. I wonder if this will work. Let's try it. Okay, so within the year is ascending because I didn't put, by default it is ascending, but the position is descending. So 247 comes first and then 34 comes later on. Okay, now the data set that I was seeing is kind of mismatches. It is not necessary that this song is actually part of this album, and the reason is we don't have enough information to connect both of this, but that would be a lesson for some other day. For now, the point was how do we make an inner join between two tables given what common values we have. Okay. Again, the drawback for this is it's not necessary that this song belongs to this album. Again, why? Because I don't have a connection. I don't have anything in my data set that is saying that this song belongs to some album. I don't have that data set. I don't have that connection. So I cannot, if somebody asks me, hey, can you tell me what songs are in this album? I cannot. Right? Your answer would be, and it's kind of a trick question. They'll be, hey, can you tell me all the songs that belong to this album? You cannot. Why? Because there's no connection between a song and an album. So you cannot tell from this data set. You need some kind of a connection, especially in the songs. There should be one more column saying an album ID or something so that you can make that connection. But it's not over there, so you cannot tell from this data set. So it's the queries that are asked are queries that are valid, and then some could be that you cannot determine. So the answer is possible that they're looking for, oh, I cannot determine from this data set or these queries that the connection that you're asking. Okay, so be careful. There could be some trick questions as well. All right, any questions? Okay. All right, so I think Lee or Sam, who's going to introduce the homework? Sam is going to introduce the next homework. All right, so this is the end of week 12. I know I say this every single week, okay, but trust me, the next 3 weeks are going to be super challenging, and I'm not even joking, okay? And the reason is we have studied everything in different components. We studied Node.js, we studied MySQL. We are going from Saturday, we're going to look at Node.js again, but the way that Node.js is popular for. Node.js is not really popular for the programs that we have been doing, but it was necessary so that we understand the syntax. We're going to create some web servers, and that's what Node.js is used for, okay? And then week 14, we're going to look at UI and then try to connect everything. Week 15, It's going to bring database, front end, back end, server, everything together. That's why it's kind of the next 3 weeks are going to be a little bit more challenging. Okay? All right, Sam is going to do the homework.